All right, so let's talk about conversions. So remember, we know from previous classes that 100 centimeters equals 1 meter. And we know that it takes 1,000 meters to equal 1 kilometer. These are equality statements, so I can write them like this. Because 1 meter divided by 100 centimeters is 1. Or 1,000 meters over 1 kilometer divided by 1 kilometer, it's still 1. No matter how I write it, all of these equal 1. So we call them conversion factors. So take mercury, for example. I know that mercury has a diameter in real life that equals 4,878 kilometers. So that's the distance across here for diameter. I cannot draw that on paper. So in order for me to scale it to centimeters, something I can measure, I have to first change kilometers to centimeters. And I can do it like this. I will take my original number, 4,878 kilometers, and I'm going to multiply that by 1, by the conversion factor that would get rid of kilometers. So if I first get rid of kilometers, 1 kilometer on bottom and 1,000 meters on top, we know from math that like things divide out, so those are gone. But I'm still not where I want to be. Meters is not what I want. I want centimeters. But I also know that for every 1 meter, there's 100 centimeters. My meters are gone. And when I multiply straight across, so 4, 8, 7, 8, 1, 2, 3, 4, 5, that's a whole lot of centimeters. And I don't want to write all that all the time, so I would write it in scientific notation. I know my decimal is here, 1, 2, 3, 4, 5, 6, 7, 8. So it would clean up to 4.878 times 10 to the 8th centimeters. Now, so my first step was to change. My second step, I need to change the actual centimeters to scaled. Now, to do that, I would want to look at my largest and my smallest. And for this case, like if I'm just seeing how small can I make it, if I did a scale of 1 to 10 to the 8, for every 1 centimeter that I draw, it's really 10 to the 8 actual centimeters. So to find out what I'm going to draw, I would just need to take my actual and divide it by my scale power to get the centimeters I draw. So I could take 4.878 times 10 to the 8th centimeters. I could divide it, maybe I want to just do 10 to the 8th. Well, that's easy math. They divide out, and I get 4.878. I can't do 3 decimal places with my centimeter rulers. So 7, the 8 makes it round up. So it would really be 4.88, which I could measure with a ruler. But maybe my really big one is still too big, like Jupiter. So maybe I decide I don't like 10 to the 8th. So maybe I want to make it smaller. So I'd still start with my actual. I could divide it by 10 to the 9. So the lovely thing about exponents, it's the same thing as like if it's a variable. We just subtract. So 8 minus 9 equals negative 1. So that means I end up with 4.878 times 10 to the negative 1 centimeters. And I know negative 1 means that the decimal would move this way. So I would write it as 0.4 9 because the 7 makes the 8 round. Still drawable, but whew, that's getting really tiny. That's like that much. I can make that small of a circle. And if I go any smaller, it could be really hard to do. This might be as small as I go. So if I like this one, I was like, yes, so then my scale will be 1 to 10 to the 9. And so for the rest of the other planets, I would divide them all by 10 to the 9. Remember, we must use the same scale. For all. You can't use 10 to the 8th for Mercury and 10 to the 10th for Jupiter. It does not work. Hope this helps.